Well, I'm grateful to be back here again with Charlie Ziese at Stargate Pyramids, and we're going to be discussing again a little bit more about the sacred geometry of the Russian pyramids. We already have a video on Charlie's channel, and this video will also be there and at my channel as well. So I'm George Leoniak of New Geometry. Really excited to be here today, sharing more discoveries about the sacred geometry of the Russian Giza pyramid. And Charlie, how are you today?
I'm doing great. Thanks, George. Hope you had a good New Year. Mine was uneventful, which meant it was great.
That sounds good. Well, we do have a short, we don't know how long it's going to be. We've got quite a number of slides to go through. Charlie and I were just recently on Sasha Stone's symposium. So that video wasn't made public. So we wanted to, take a lot of the material that we had in there, make it available to our channels and add more additional information that we had to, leave out of that video. So if you've seen that already, you might want to stick around for this one. And if you're new to this, you're going to get a double dose of a lot of material coming up that we've tried to condense into this one. So I'd say, Charlie, you're going to lead us off to jump into it.
Okay.
So why don't you take it away?
All right. I'm going to share my screen here. And these are essentially the same slides. We put in some new material as well. A lot of you have seen a lot of the examples of this that I showed to the general audience. So I've cut out some of those. But, just to start with, we're going to be talking about sacred geometry and the organizing principles of the universe. Essentially, what we're going to show is that mankind has known about this specific geometry. It's the geometry, it's one of several, I guess, geometries of phi spirals that we can find, but this seems to be the one that nature uses to scale everything from the subatomic to the galactic. And what we're going to be showing today is that mankind has used this very same geometry in architecture for thousands of years. But most importantly, in the second half of the presentation, George and I got together about 6 or 7 weeks ago now, and George was working on trying to develop sacred geometry drawings of the Russian pyramid. We came across each other. He saw a video that I had done where I was correlating, the Platonic solids with the Russian pyramid geometry, and that's how we got started. But George is going to be presenting what is going to be, I think, for the first time, other than at Sasha's event, we're going to be demonstrating that we can combine this 76.345 geometry with the scaling of fractals, with the scaling of the Platonic solids, and all of this will fit inside a spherical torus. So essentially, we have put together for the first time, a true model that links all of these things together. So that's where we're going to start. And these are just 3 examples of buildings. One is on the left is the new Amazon headquarters in Arlington, Virginia. The middle picture is a drawing called Babylonus Murai. And then finally, the Great Mosque of Samarra, Iraq. These are just 3 examples that we see of this geometry. Now, I didn't mention this during Sasha's because we were rushed for time, but if you'll notice, one of the things that's different on this page is the fact that the Amazon headquarters, the spiral is actually going in an opposite direction from the other 2. And I don't know exactly why they did that, but the normal way of drawing this, because this is the way scientists have determined that they flow, is with what's called the right-hand rule. If you hold a pen in your hand and your thumb is pointing upward, the direction here should be spinning is the direction that your fingers are wrapping around the pen, and that would be in a clockwise direction, as in the left and right. So I can't tell you why they chose to do it in an opposite direction, but there must be, or there could be, some symbolic meaning there. Anyway, go ahead, George.
I didn't have anything to say there, Charlie.
Oh, okay. That was just me. I'm coughing a little bit here.
Oh, you want me to take over with your slides?
Let's, no, I can't do that. Let's see what's going on here. Let's try to get this.
Let's see if you can
It's not,
advance.
it's not letting me advance. What's going on?
The arrow on the keyboard, down arrow, does that work for you?
Well, let's find out. There we go. Okay, so sorry for that, but just by way of introduction, civilizations around the world have used sacred geometry for free energy and healing for thousands of years, yet we're not aware of any of this. And that's what my book is really all about, is to point this out. Evidence of this is hiding in plain sight in architecture, which was my primary focus. It's in hieroglyphs, it's in technology, both ancient and contemporary, as well as in sacred geometry diagrams that George is going to be showing you later in the presentation. Now, the phi spiral is a classic example of one of these hidden sacred geometry technologies. Nikolai Kozyrev, who is considered to be the father of torsion physics, he proved the existence of these spiraling torsion fields in the 1950s, and Victor Schauberger used the spirals in water as the inspiration for his free energy technologies as well, and we'll be talking about all of these later in the presentation. But our knowledge of sacred geometry has been suppressed in large part by the elimination of the study of the quadrivium. Now, the quadrivium is an advanced course of study that was taught by Plato and has its origins back probably to Pythagoras, if not earlier. But it combined mathematics, harmonics, geometry, and cosmology. So all of that sacred knowledge was lost at the beginning of the Renaissance because the decision was made to no longer teach that. Interestingly enough, it was precisely at that time that the Gothic cathedral construction came to an end as well. So, I mean, to me, it doesn't sound like we entered into a Renaissance. We probably went into the Dark Ages at the beginning of the Renaissance, and George may have some comments on that too later. But just to finish up, I mean, it's really one of the greatest tragedies, I think, that's ever been perpetrated on mankind, because the quadrivium, the purpose of study of the quadrivium is to find first causes or first principles, such as the organizing principles of matter in the universe that we're going to be talking about today. So briefly, for those on my channel, you've seen this before, but this is basically how I was able to re-engineer the geometry of the Russian pyramids. I took a protractor app and was able to measure. It doesn't come out this precisely the first time you do it, but I knew I was going to be very close to 76.345 degrees by just doing a direct measurement of a picture. And knowing that the phi spiral was so important to Kozyrev and to others in the field of torsion physics, I decided that I wanted to see what would happen if you look at the middle diagram that's with a black background. That's what I conceptualized, a series of spheres stacked on top of each other, where these torsion fields would be flowing around these spheres, so to speak. And when I did the mathematics on that and determined the slant or slope angle, it turned out to be 76.345 degrees, which matched up perfectly with that of the Russian pyramids. So I was feeling good about this. I started to feel even better a couple of weeks later when I actually realized that 76.345 degree geometry is shared with the Giza pyramid as well. A lot of my customers were asking me, well, Charlie, is there any relationship between the Giza and the Russian pyramids? Because they look so different. But what I did find out was that, sure enough, they share this common angle. On the diagram on the left, you'll see bottom point F here, 76.345 is what's called the slant or slope angle of the Russian pyramid, which is the taller one. But then here at point E, which is the top of the Giza pyramid, you'll see that this very same angle exists. So I knew now at this point that this was highly significant. Now, the next step was to actually find this in nature, and this is when I really knew that this was significant, because I found that nature uses this as a scaling factor for light. Number one, light refracts through a glass sphere at this very geometry. The amplification of sound through a megaphone occurs with a megaphone of exactly this geometry. Water, when allowed to create its own funnel, kind of in an unobstructed fashion, ends up, that funnel turns out to have that same slant angle of 76.345 degrees. And finally, we find it in our DNA as well. So this is fundamental to essentially to all aspects of creation and scaling in nature. So again, highly significant. So now I want to just show you quickly some of the places where we found this geometry. These are just a couple out of hundreds. I have over 1,000 examples in the book of photographs of examples of this. But all of the Egyptian obelisks, which are all also related to free energy generation, have this geometry in the pyramidal tops of all of the obelisks. This is what's called a nuraghi. It's in the island of Sardinia in the Mediterranean Sea. There were approximately upwards to 20,000 of these that are estimated to have been built on this island. What's interesting about this island is the fact that next to many of these nuraghis, we find burial sites for giants, for certainly creatures that were much larger than ourselves. And one has to question, knowing, as you'll find out, that this geometry, because of its special nature, it's organizing the fields in a coherent fashion, whether that maybe had an effect on the size or the height of these giants. But today, Sardinia is a blue zone, which means that it's one of the areas on the planet that has the highest life expectancy. And I do believe that that is in large part due to the fact that these nuraghis are organizing the field to produce health and longevity. All of the Brochs in Scotland have this geometry. The Great Zimbabwe Ruin in Africa has this. In 2020, Michael Tellinger and Dr. Sam Osmanagich measured a very, very large ionization field coming off of this conical structure. And research at the University of London, as corroborated by the Russian pyramid research, indicate that ionization equates to higher or immune function. Now, here's an example of a southern style Dravidian Hindu temple called the Thiruvannamalai Hindu temple. We're going to see some more contemporary examples of free energy, but this is an example of an ancient structure that is believed to have been actually a power plant prior to its incarnation as a temple. In the top left-hand corner of this screen, we see YouTuber Praveen Mohan. He has a video on this temple and indicates, as he's pointing to there, that there is a drawing at the base of the temple indicating that a gigantic Tesla coil is buried inside this temple, and is probably the source that was used, ground energies, to bring into the temple, which were then magnified and clarified through the geometry of 76.345. And also at the top, you'll notice there are up here there are 13 balls at the top of the temple. These most likely contained mercury, and that was part of the free energy process that was used at the temple. Here's another. This is a Buddhist temple in India as well. You'll see this geometry, as well as a coil at the top of the temple, which has this geometry as well. virtually all of the Gothic cathedrals, this is one of them, that about 2/3 have this very geometry in the steeples in these Gothic cathedrals. And these Gothic cathedrals were built from about 1100 to 14 to 1500. So these were, I looked at every single Gothic cathedral that was listed in Wikipedia, and I'd say probably 2/3 of them have this geometry. Another 15% or so have other geometries that we know are associated with the golden ratio. So, I hope that between George and me, we'll be able to figure out the other 10 to 15%, in the near future. Here's an example of a castle, Königsberg Castle in Germany. Again, this geometry is found. This is an example. You see this as well on many churches where the central steeple is surrounded on each corner by 4 smaller ones of the same geometry, at just a different scale. And you'll notice these balls on top of each of these that indicate there was mercury involved as well in the free energy process. Here is San Marco Bell Tower in Venice, Italy. Virtually all bell towers around the world use this geometry, as we saw earlier. In the megaphone example, it helps to amplify the sound coming from the bell towers. Here's an example of Tartarian architecture. Tartaria was an empire that is reputed to have been worldwide. And that technology is probably spread by this civilization around the world, and that's why we see it. But this is an example. This is St. Basil's Cathedral in Moscow, which we deem to be part of the Kremlin, but you'll see here that this geometry is found in the towers. There's other types of antiquitech here as well, called onion domes. That's the green and blue towers that you see here as well as the mercury balls, as well as fractal antennas. So they were using a lot of different technology here to create free energy, but this is an example and you can find this in variations around the world. Here's another example, one that you wouldn't normally think about, but I remember I found the Erlenmeyer flask. Has this geometry as well. Emil Erlenmeyer was a 19th century German organic chemist, and he did a lot of research into double bonding of certain carbon compounds. And what he found apparently was that the geometry of the beaker was very important in the success of many of his organic chemistry experiments. And this particular flask has now become essentially the industry standard for chemical experiments, particularly in organic chemistry. Now, I just wanted to point briefly, I'm going to take you up to the early 1900s. Church steeples had mimicked the Gothic cathedral geometries in what's called the neo-Gothic style, and that continued up until around the beginning of the 1900s, when we suddenly saw that geometry totally disappear from Western religious architecture. Now, Hindu temples, Eastern Orthodox, Russian Orthodox churches, they all continue to use it, but it has been specifically, eradicated in the West. And that seems to have been done on purpose. Architects starting at the beginning of the 20th century who attempted to use sacred geometry were vilified and ridiculed, saying that this was just an ancient relic that had no purpose. And of course, what George and I are trying to do is to disprove that notion and bring this knowledge back to the people. Even though it left us in secular and religious architecture, we do find this geometry, however, in high tech. And so it's alive and well, it's just not alive and well in the public education system. So here's an example of a power plant cooling tower. These are used on both coal and nuclear power plants. And essentially what they do is they are a mechanism whereby you can cool down the steam and recycle that water and use it again and again, rather than taking that hot water and putting it, you having to bring in fresh water all the time. So an example of the technology at use in a peaceful, purpose. But now we're going to get into military technology and aerospace technology. Virtually all of our rockets, missiles, aircraft, all have this. This is a Saturn I rocket. This is a MiG-29 aircraft, a fighter jet from Russia has this geometry. SpaceX, Sputnik. So both aerospace programs know about this geometry as well. And here's an example of a concept vehicle that Lockheed Martin has put out for hypersonic travel called the SR-72. So this geometry, people know about it in the high-tech world, and we use it. But as I say, we're finding this. It's not in our textbooks. It's not in our science curriculum. But interestingly enough, all of the aerospace engineers have figured this out, probably through the use of wind tunnels and the like, because sacred geometry is not taught in engineering schools either. So kind of with that, that's where we're going to stop our brief introduction into the pictures. But I want to go over now, as kind of a segue into George's section, some of the other information that I picked up that had me believing that we could put together a unified model of the creative process. And so that's what I want to show you. The first thing I want to point out is that fractals scale in the geometry of phi cubed. We're going to be talking about that concept going forward, so keep it in mind. This is a drawing from Richard Merrick's book called Interference. He has developed an entire book on a harmonic theory of creation, and I think it's must reading for people who are really interested in trying to understand a harmonic view of how creation occurs. But in this book, he took what's called a Mandelbrot set. This is a classic depiction of fractals this design came from the work of Benoit Mandelbrot in the 1970s. He's credited with discovering fractals. However, fractals go back at least to the ancient Vedas. So even though he discovered them, he actually was rediscovering all of this ancient knowledge, just as George and I are trying to do now. But each of these circles, if you look at that very tiny circle, he scaled that as phi, and then the next circle, phi cubed, the next larger one, phi to the 6th, and then the last one to phi to the 9th. So we're seeing this phi cubed scaling unit or octave in fractals. And when we look here on the right side, phi cubed is equal to 4.236, which is the slant height ratio of the pyramids that we've been discussing earlier in the presentation. Now, similarly, the Platonic solids scale in this ratio of phi cubed as well. I kind of saw that if you look at the diagram on the left side of the page. This is from the last page of Robert Lawler's book, Sacred Geometry, Philosophy, and Practice. And when I saw that this is a two-dimensional depiction of the Platonic solids, and not really all of the solids are even in this diagram, but when I saw the circumscribing and interscribing circles in this diagram, I immediately started to see this in 3D and saw it as a cone with the very geometry that we were talking about. And sure enough, when you go through the calculations, for those familiar with it, I mean, there is a theory that the Platonic solids move from one form to the next in a continuous progression, just like keys on a keyboard on the piano. So when you look at the ratio here, we go from an icosahedron to an octahedron, tetrahedron, cube, dodecahedron, and then back to icosahedron again. Well, those could be viewed as the two icosahedrons as like C octaves on a piano keyboard. And when you check out the ratio of the circumscribing diameters of the circumscribing spheres or circles, you find this very same 4.236 or phi cubed geometry. So, we now know that both Platonic solids and fractals are going to scale in that proportion. And here's the most important and the last thing I'm going to talk about before I turn it over to George is the fact that a spherical torus can accommodate this very 76.345 geometry. Now, most of the pictures of a torus that you find on the internet are really just artist depictions, and so you really can't make much out of them. But this is a specific award. It's called the Breakthrough Prize in Fundamental Physics. This is the most financially lucrative science award that's given out on the planet. And when I saw this, I had to measure it because I knew that this specific torus was spherical. So there's a video that a woman called Fractal Woman on YouTube had put together, and she had discussed the fact that in order to keep this spherical, that the z-axis or the vertical axis has to be scaled in phi. So I thought this was extremely important because now all of a sudden we have the ability to scale inside the torus, which is assumed to be the best model of the organizing principles of nature. And we know that the geometry and the scaling is all going to fit together. So, with that said, what would that, I just want to show you quickly what that would look like. Essentially, what I'm saying is you could kind of interpose that pyramidal structure that I had devised, earlier in the presentation, and that can show you kind of that's the under half of the pyramid of the torus, and that's what's going to be powering the pyramid, or excuse me, the torus movement. So with that said, I'm going to turn it over now to George, because George is now going to demonstrate those very principles that we talked about, putting all of this together in a model. And this is something that we've never seen before. So this is very exciting and powerful information. So George,
Great.
look forward
Yeah,
to
great.
taking it
Oh,
over.
yeah. So, well, I'm coming on. Thanks so much for sharing that. And I just love seeing the pictures again. It's just amazing to me how many places of the 1,000 places in the book. I mean, the book is, people haven't seen it before. It's gigantic. I mean, there's so many images in it, and just so much research went into that to show where this angle of the 76.345 shows up in so many places. And in your presentation there, you're like, you can't find any examples of it in the textbooks and education. And you would think, right, that it would be in sacred geometry books somewhere. Like, because I've got a mountain of sacred geometry books, that I have at my home here. And I flipped through all of them, and I can't find one technique in any of these books, other than one that was just published maybe a few years ago. There's a reprint. It's called Patterns of Eternity by Malcolm Stewart. It's about the star-cut diagram. That's how I got interested in this pyramid. He has a picture of the Russian pyramid, and in there he tries to do an example of trying to show how the slope angle fits on those stacked phi ratio spheres. But I noticed it was a little off. And that was really about 2 months ago, prior to meeting Charlie, because people who don't know me from Charlie's channel, I work with the golden ratio circles. I mean, Platonic solids, so much geometry is about the golden ratio that I do. So I was like, I must be able to find this in these templates that I work with regularly. And sure enough, after putting my mind to it like that, it started to show up there, but all over the place. And it was right there in front of me the whole time. So it was like hidden in plain sight in these diagrams that I can't even find a reference to in sacred geometry diagram books at all. So it's really amazing to me.
Now, George, I have to ask you at this point, I think that this has all been done on purpose. Do you think that knowledge of this angle may have been suppressed out of sacred geometry texts?
Well, I mean, my texts only go back to a certain date, right? I mean, most of them
Yeah.
are modern authors. I don't have anything really, falling apart at the binding or anything like that. But we'll see examples of von Welling's drawing up to like 300 years ago that had a depiction of perfect Russian pyramids. I have that image in my slideshow. So somewhere 300, 500 years ago, those architects that were building all the cathedrals and the things that you showed us, they must have had some sort of compass and straight edge know-how about how to reproduce this to put it on paper that somehow eluded our modern education of sacred geometry, which is already pretty much out of the major education, right? So the type of things you're going to see that I'm going to show you, I feel are really cutting edge and revolutionary. And it's kind of, I'm excited to share this all with you here. And I'm also excited to share it. I've got a class coming up. I'll tell you right now, Charlie and I are going to be, Charlie's going to be in the class this coming Monday, January 9th.
You won't
Three-session
be
work.
teaching. I will not be teaching. I am a student.
Charlie's going to be a student on that, but he's going to share all sorts of other insights, I'm sure. But I'm going to teach a lot of the techniques you're going to see here. Not all of them. Some are more technical, but I feel like this is a way to get it back into the pattern language of sacred geometry and introduce it back into the stream that may have been diverted somewhere. And these techniques are sacred geometry principles that are going to be infused back into a kind of cultural element, bringing it back to the people, as Charlie had said, to see whatever it inspires and sends you on your path at sacred geometry. But that's enough of an intro. Let me show you some of the slides. And I'm not going to go through a major demonstrations of the drawings here, but you'll get enough of the insights of what it looks like and, just what some of the designs, which one is it here? This one here. What the patterns look like, and then what do they inform us about the types of, you got the screen, Charlie? Is it on?
You're fine. You're fine.
Okay, I got it. Okay. Let me get rid of this sidebar. So we're going to get a sense of just, what these patterns look like and really how this information, magically relates to the types of things Charlie was sharing, especially those last few slides about the torus and its relationship to the Platonic solids. This is just really a kind of an overview slide of one of the techniques that I discovered that create the Russian pyramid here, shown in blue, and the Giza pyramid here is shown in red. Early on in Charlie's presentation, he showed another example of the Giza pyramid down here in the Russian pyramid, and I have techniques to draw it that way too. So, I mean, I've got 26 techniques that I can draw this angle, when about 2 months ago, I had zero and really no reference point of even how to do it. And basically, I applied my knowledge base with the phi ratio and these templates to looking for this angle and came up with 26 unique methods of how to discover it, which is just amazing to me. But let's just talk about the numbers a little bit here of what's going on. I'm basing this drawing on a 1-inch base length of the Russian pyramid here. So that's going to give us, a height here of 2.05. And then this is the slope height, which is 2.1180. So that's the half of phi cubed number that Charlie was pointing out before. We also have the Giza pyramid here and the base. These are all models that I've constructed here, so we can actually look at the relationship between the two. So all this stuff is transferable between the two images, but I don't want to bog you down in the numbers. Basically, you don't have to do any numbers at all. This is all easy to do with just drawing circles and golden ratio circles. And I found out one of the first drawings that I did put this whole diagram into one of the most iconic drawings in sacred geometry. It's called Squaring the Circle. Now, this is something like a geometer's alchemical puzzle, because basically what this design of the square and the circle, you're trying to create those so that you have a circumference of the circle that's equal to the perimeter of the square. And the way I do this is with a golden ratio Giza pyramid, and our Russian pyramid fits right inside this ancient alchemical design of the square and the circle. So this is one we're going to do together in the workshop, probably the first drawing we do, because it's not that difficult to do, and you'll be amazed that the pyramid shows up just like that. and it was there the whole time. I never knew it. So, Charlie, you feel free to jump in anytime you want here if you have questions or comments.
I will.
Okay. Just I didn't know if you were poised to say anything there. So that's one example. But like I said, I have many different styles and techniques of creating this. This is kind of the same design as the first one. The other thing I notice is that the relationship of the Giza pyramid, where it intersects the circle that is at the base of the Giza pyramid, it actually gives you the point to send the Russian pyramid angle, the 76.345, right back to the center of that circle. Later, you're going to see that that's going to become a sphere, and this simple diagram that I'm showing you here is the one that's going to relate to the torus. All right, so we're going to put that all into the structural geometry, but just this simple line of the Giza pyramid intersecting that circle provides the 76.345 angle. That to me was just amazing because I've drawn this a gazillion times and never thought to draw this line back to the center. I mean, I missed it so many times in my studies of like, there was no, it was like invisible to me. It was amazing, Charlie, that it was just like, why would I draw that line? I'm usually focused somewhere else, but there it is. It's that easy.
It is. Sure.
So it's not like it's a hidden mysterious thing, but the funny thing is to me, well, not funny. I mean, the weird thing is it's not in any book. You know, it's not like that simple technique or this angle that Charlie's talking about that was all that ancient architecture, you know, is nowhere to be found in the modern, even sacred geometry texts. So, so here are the two models of these. And in there, we're going to draw these and we're going to make the models. I'm going to show you the templates of even how to make the models from sacred geometry techniques. So we have a design where here, if I fold up these edges of these triangles on that base of the square, check it out here, like this. This is the outer template of the form. If I fold those up, that's the Giza pyramid, okay? That's what you're looking at right here. And right inside that little template, it already contains the Russian pyramid right in there. It's part of the design. So it's not like this is something that is just, you know, some scientific study or whatever. It's right at the heart of sacred geometry techniques. It was in there all along. So the base of that, basically, that yellow square in the middle is that square, and this base here is the big square that you see, right? So we basically just folded up these edges, and there you go, fold it up, and you got the two pyramids, one inside the other. And it's all simply done with compass and straight edge and knowing what lines to connect. And these are the things I'll be sharing, you know, in various different ways. And I think Charlie and I do have probably, I don't know, maybe drop a little nugget out in the coming attractions, possibly trying to work another little book and put some of these techniques down in paper, revising some material, you know, getting the sacred geometry in there. So something we discussed a little while ago, but I'll put it out there. I think it's very important to document these techniques, not only in the video sense like we're doing, but also giving you the ancient text in a modern format of how to do this stuff.
Sure.
So now let's just go back to the Platonic solids that Charlie showed. This diagram that you're looking at, and it may look busy if you're not used to looking at this, but this looks like Robert Lawler's diagram at the back of the book. What I've done here is nesting the Platonic solids. This is a big blue icosahedron, this blue one with the crossing lines. There's a dodecahedron in here. This black square is a cube. Now we're going to keep going to the next black cube that's way down in here, and further into this is another black cube. That one is 1 inch. The medium one is 4.236. We heard that. That's phi cubed. Up to this cube, which is the multiple of phi cube again, phi to the 6. This is going to be the 17.944. And we could just continue this expansion out of the Platonic solids. But notice at each level of the Platonic solids, there's that pyramid angle going from the cube, smallest cube, up to the next cube that would be this box here, right? So this cube right here, this black cube, that pyramid goes off that sphere all the way up till we reach the next largest cube that contains the whole diagram. So that's going to continue on. That's the V4 to G1, or C1, right? C7, V4 to C7. That's that big cube. That's the 17.94. That's the 4.236. This one right here is 1. So those are the 3 boxes. I might have put an extra box in there. But basically, you can see what is happening is that 1 cube to the next cube, the next time that cube shows up, is going to be phi cubed, a multiple of phi cubed, on and on and on. So that's a real fractal scaling that's going on there. And I'll just jump ahead quickly because I'll skip these next few slides, because today I noticed in a video that Charlie and I did previously, there was a viewer that said, hey, this looks like it relates to Dan Winter's, some of Dan Winter's implosion work. Now, Dan was on the video that Charlie and I did at the symposium, and Dan and I have done a video particularly around his star mother sacred geometry, because he describes this as the only 3D fractal, or an example of sacred geometry or geometry that shows 3D fractal in all directions. And that basically, once we go through the basic Platonic solids, octahedron, tetrahedron, cube, once you get to that point, you have cubes in the dodecahedron, 5 in there. And that will stellate to this small stellated dodeca, which creates the vertices to create this icosahedron. Once you go to this icosahedron, you stellate that, and then that becomes this form, which creates another dodecahedron. So basically from this, if you stellate this dodecahedron, well, that's going to look like this, and that will create another, icosahedron. And then you stellate that icosahedron, it creates another dodecahedron, stellation back and forth. Now the jump from dodeca to dodeca right here is 1 to phi cubed. The jump from icosa to the next icosahedron is phi cubed. The jump from any of these forms to the next form is going to be phi cubed in this scaling factor around phi cubed. So just like Charlie showed with the Mandelbrot set of that fractal expansion on a 2D plane, right? Of seeing how the interference book of Richard Merrick, right? He had that interference model showing how the Mandelbrot set is expanding in those circles. Now picture that 3-dimensionally around these objects, and every fractalization to the next one was a multiple of phi cubed going on and on. That's why this is a 3D fractal that Dan is describing, and why this is, sacred geometry that isn't 2D anymore. This is, in the hand, material of, there's the icosahedron, the dodeca, it's all down in there. So, okay, so I just wanted to jump to that, but let's just back up a bit.
Before you leave there, could we go back to that slide? Yes, a lot of my viewers are probably, and I'm not totally familiar with stellation. Could you kind of explain stellation process for my viewers?
Yes. So what's happening here is that if we have a pentagon face of this dodecahedron, and we extend the edges of the pentagon has 5 edges, right? So if you extend those edges until they meet again, right? So let's follow it out on the small stellated dodecahedron. I extend that edge up this way, but meanwhile, that edge is extending and it meets over here. So when those two meet, it creates a star, right? It's going to create 1, 2, 3, 4, 5, because that meeting place is now a new vertice in space. And when I connect those vertices in this form, even though it looks like it's separate, but if I go 1, 2, 3, that's that triangle right at the top, right?
Okay.
Now, if I extend these edges, right, extending that edge, well, I'm going to extend it, that little triangle right there in the middle, that's the same size as that triangle. So you extend that edge and you extend the other edges, well, they're going to all meet and they're going to create the new vertices in the distance here that then create the 20 vertices of this dodecahedron. Repeat the process. Just extend these edges, right? You're going to do this form at a next larger scale. The thing is there will be a next larger scale. And what I'm saying, the next small stellated dodecahedron of this one up here, when you extend those edges, that's going to be a jump of phi cubed, right?
Got it.
Got it. Yeah.
Okay.
So stellations are really amazing. It's what creates the fractal movement of this three-dimensional geometry, and it all relates to these phi-base forms. They're really, and that's why in the pyramid we're stacking in phi-base circles, because there's something about phi and fractality, right? And that's why the Mandelbrot set, when you draw those circles, and why phi cubes keep showing up in that, even with three-dimensional geometry like this, compared to a 2D Mandelbrot set, or compared to how the pyramid is showing up, in the slope angle to the base, slope to height angle. It's just amazing, right? The phi cube seems to be mysteriously linked somehow behind the scenes to all this.
Right.
So, this was known in the past. I mean, what Charlie's book was all about, right? I mean, you showed so many examples, and this is one of the first ones Charlie sent me here, was the Egyptian hieroglyph of the Temple of Karnak. And I had just done this drawing, and it was our first meeting, actually, and I showed you this, and you got so excited. And later that day, you were like, you sent this to me, and I laid this over top. So these are the same. Let me just try to describe this. Each of these pyramids you see in here are based off of the in-sphere or out-sphere of one of these Platonic solids. So the out-sphere would just be put a Platonic solid in a sphere that's around it, and the in-sphere would be the sphere inside it. So I basically made pyramids off of each of those. And then I just laid it right over top of this carved-in stone and Egyptian hieroglyph. And look at that, the little gap between the two showed up between a relationship between two of these spheres, of the in-sphere and out-sphere of these two forms. It would be basically the out-sphere of the icosahedron to the in-sphere of the icosahedron. That was what that one was. In-sphere and out-sphere was this distance between those two on that one, which was really kind of wild. And then even the little notch that was cut in the bottom was this darker one down here, right? So anyway, we gotta debrief these and kind of really look at these ancient diagrams. Here's another one, for example. Charlie had this in his book as well. I took the same diagram, laid the Russian pyramid stack related to the Platonic solids over the Aztec count, which is just got stacks of pyramids all the way through it, right? Look how many times the pyramid point shows up in here. And the central circle, I just lined up the central circle around this cube, which is around that octahedron, which is the 8-sided Platonic form. I know I'm just dropping names left and right here, but that's the octahedron, right? That's right here, the blue one, right in the middle of that square. There's a sphere around that. There's a circle that I've drawn. I lined it up right on the face, the circle around the face. And just let's see what happened, right? Well, there we go. Everything just stacks up. Look at this. That hits that circle. This is right here in the notch of that pyramid. That's at the notch of that pyramid, right back to the circle. And those pyramids, remember, they're coming off of the in-sphere and out-sphere of Platonic solids. So, I'm not saying that's how they did it or they knew all that. Maybe, I don't really know, but it seemed to fit really pretty nice where we see those points showing up, right? So it's, speculative geometry here for sure, but correlations that show this was definitely constructed with some knowledge of 76.345 all throughout. That's not even like really a question. So, here just to simplify the drawing, taking the Platonic solids out, just to show, if we take out all those in-spheres and out-spheres of all those forms, and we just do these jumps of how the circles way down in the middle here is the 1-inch one, but we're just jumping along, boom, 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 boom. The next one would come off of this circle and we'd be off the page, right? But each of those are these fractal expansions that we're describing. And it really seems to be driven by this pyramid that is kind of keeping that scaling factor. Now, I don't want to keep calling it just a pyramid because that always implies a square base. The cone inside of it is really what I'm going to switch to now, because that's what's going to be holding, like if we turn it into a torus, right, which is like a sphere. So we're really dealing with something that's like a vortex, like water going down a drain, right? So that's a cone, but there's it's encased in like a three-dimensional, 3D type of shape. So in this is something we'll build in the class, just this size too. Here's the cone that I made that we're going to make too, that fits right inside. So really it's holding the stacked phi ratio spheres, and it's also creating the slant angle of a circular base of the cone that we're going to discuss. So this is that cone on our page now, on the presentation. And we wanted to look at how this relates to the golden spiral, because what's going to happen with these golden ratio spheres is that they're really kind of like guideposts for the spiral path to follow. Because this spiral, in order for it to be a golden spiral, means it's going from one golden ratio sphere to the next golden ratio sphere to the next golden ratio sphere, as if they were stacked one on top of another. So pretend this is the same form, which it is scaled to it, and we got a stack of spheres on top of one another from the top down view. And if you really want to pause the video at some point and study this, you can kind of have fun going around, because if we start over here on the left, that's the left side of where this spiral starts. And I know this is square version, but it's easy to draw it that way. Now we're going to go to the back of the cone or the pyramid right over here. And we're going to go over to the right side, which is here, right? And we're going to go towards us, which is up over here. And we're going to hop over to the left again. And you see how that's working, right? We're kind of just, this is a spiral going down and around as it follows this progression in a golden spiral, which will look just like this from above. It will look flat. And I'll illustrate that in, not that slide, but this slide. So what I did was I took that same cone with the 76.34 angle, and I mapped out those straight lines. These aren't even curved lines. They're just those same straight lines, folded it up. And when we look down at the top of the cone, what do we see? Well, it looks like a flat spiral, right? Just circular going around. And that's the ascent or descent of that spiral. It's on the backside coming up to the top. And of course, we could do that from the 8 directions like I've shown here. So we have 8 directions shown. We have 4 spirals on this one, but I did that same thing with the 8 spirals, and it creates this geometry, what some geometers look like might be a kind of image of light or some sort of sound wave structure with these kind of crisscrossing, overlapping spirals of light, often called. So just want to let you know, like, I came up with a really nifty method, a few that produced that cone with just hand-drawn sacred geometry techniques to like 99.99% accuracy, which I was happy with. Because you're dealing with the circumference of a circle, which is pi, and you got all these factors, and you're looking and hunting around like, where's this intersection going to be to cut that out, right? But look, I could put it right in there, and that's what this little cone here, it fits into this pyramid that we just fold up. So it's just part of the craft, right? It's like, you really, I'm hopefully inspiring you to like check out this workshop. Even if you can't make the live, there will be video recordings of this, because if you want to make a wizard hat, and I know Charlie took out the dunce cap picture in his slideshow, but it is more a wizard's cap than a dunce cap, right? And there had to be some sort of psychological repression in the dunce cap view of why that would be the case. But if you want to make for Halloween or birthday parties or whatever, and you want to know how to make some sweet 76.345 cones, I got a hand-drawn method. It's going to make it 99.9%. And if you make a mistake, it might be 100% accurate. So anyway, it's very cool. I love finding a method for it. It was really pushed my sacred geometry skills to another level trying to figure that out. So I'm grateful that I can share that with you, because you have to wonder how they did it to make a conical shape, or how they, for a big cathedral or something like the images Charlie's showing. Like, we better test that out with paper first, or something small, before we just go at it, right? So this reinvigorates the pattern language and really introduces some things I don't think you're going to find anywhere else, unless it's, of course, buried away in some secret society or something like that. But for whatever it's worth, I dug through this for the past 2 months as like my sole focus to discover so many amazing things about this that relate to the pattern language of sacred geometry that are now free for everybody, free for all to have. It's going to be out there. It's going to keep going. So check it out. Here is the rhombic tricontahedron, and this is goes back to the Platonic solids. This form is a 30-sided shape, And it's now a form that's made of the icosahedron and dodecahedron. I didn't go over this a lot, but it's a form that relates to the Earth grid, which I'll describe shortly. There's a sphere that was inside this form, and our cone intersects that sphere. So that's that same 76.345 angle. Now that sphere inside there is thought to be an Earth, let's just say, or, definitely a spherical shape. And this is Charlie's image that he sent me around the 76.345 nice spherical torus. So I just, drag and drop, take a look, right? Well, there's our nice sphere of this inside this form. There's our two cones. There's our, phi ratio stack. And there's our spiral. And this is what that spiral would look like as it kind of goes around the outside, gets back to the point at the top, and now spirals down the top back to the 0 point, or whatever you'd like to call it, kind of at the middle of that whole torus structure. So, it's just, it's right there. It's like, this is really like a conceptual view. We really need probably more people on the team who can animate this stuff for us and, make it a living thing. But all I know is that the sacred geometry in the 2D, which is a great place to start, everything works out. There isn't any fudging around here. In fact, that's a good point. Like Charlie's numbers for his method of how he approached this compared to the methods that I used, they were exactly the same.
The same, yeah.
All the way out as far as the digits gave us in the GeoGebra programs we gave us.
Right.
So once you stack golden ratio spheres like this, there's no wiggle room for error, let's just say. I mean, it's just like a fact. Stack spheres like this, you put a tangent line to each of these spheres, that's going to be 76.345 degree angle. It's like that. So Charlie's and I's methods produce the same things. Let me just check the time here, Charlie. Okay, I got to move along a little bit. So
fine, don't worry about it.
Okay. So we have, another example of the golden ratio nested rhombic trichontahedron. This is now a nest of those trichontahedron going at increments of phi all the way down, blue all the way to blue. That's the square root of phi. And we got those cones going from all the directions. I think this would make a pretty cool looking piece of jewelry, having the little glass beads of something woven around the spirals around the outside. So, I love to see this type of material become, items that manifest, and creative people who have those types of interests can have a field day reproducing beautiful artistic creations using this angle. This is a ley lines of the Earth grid model that I constructed using sacred geometry techniques. Let me just touch on that briefly. I have a video series on this, but I did make some connections to the Earth grid. Of course, this is done by Russian scientists over here, that a latent icosahedral symmetry is taken further by Becker and Huygens, and looking at that trichontahedron shape, this sloping shape in here is the surface of the Earth. See how it comes in contact with the trichontahedron right at the center of those vertices? If I draw a circle right there, that's where the cone is, right? So that cone is on each of these 30 faces, and it's also even on the pentagon faces, which I'll show you in just a moment, that are part of that form. Each of these white dots would represent one of those points. Okay, and here would be the Great Pyramid, is located within miles of that location. So that big red thing up at the top there, that triangle, that's the Great Pyramid. And that cone, is positioned, right underneath one of those spots that would go in there. Of course, this is not to scale. Let's keep going along here. Okay, so we looked at the trichontahedron in the square face of the diamond shape. Now I also wanted to check out the pentagon face, and saw that when we look at the dodecahedron and put the cone into the dodecahedron, the circle that fits right within the pentagram star within that's made of 5 cubes. That circle is the same one that would incrementally get smaller as we go through a stacked series of phi ratio progressions. So each of these flat red, blue, black dodecahedron pentagons are the same that you see from left to right here, okay? So one is at the base, and in there you have a little circle, and another circle there, and another circle there, and another circle at the top. Now, each of those are the perfect circle that would fit right in there, and it's fitting right to the scaling factor through these dodecahedron. Now, this is important for, the way Dan Winter looks at and his implosion model is based on the pentagon and the dodecahedron, and this 76.345 angle is straight at the heart of that pentagon face. It's right in the central pentagram at the center of that, the small pentagon. So we can draw this as well, and I made a model of it just to depict what the cones look like in the dodecahedron, and that's what this complete model looks like. Here, I have it right here. So basically what I did was I put the blue cone is the 76.345 cone. Now it's coming in from 12 different directions inside the dodecahedron, and this larger cone that's in there, that's more related to, now we're gonna get into this, we didn't get into this in the symposium with Dan, but I had these slides and I need to put them in somewhere. So I'm gonna drop them in now, because Dan has a cone, Dan Winter that is, and his research has a cone based on the dodecahedron cone, which is this cone. And he calls it a braided caduceus, as it kind of zigzags back and forth, these red and blue zigzag lines. Well, what do you know, that when I put the Russian pyramid into the middle of that, those circles are going to stack at the increments, these gold lines that are going across, is right at the center of this cone going into the center too. So there's definitely a relationship there to explore, and I'll be talking more with Dan about this, because inside this cone that Dan has in the dodecahedron and the swirl, the spiral that goes around there, it's actually reproducing the stacked spheres of the Russian pyramid geometry right inside that. Okay.
Yeah.
And it's these two circles that I'm highlighting, this one, and it's all in that dodecahedron structure. So this is more to explore here,
Can I ask a question back there on that slide? I know the previous slide. No, the one before it. Yeah,
this one.
The blue cones. No, well, either one. Yeah, the 63.4 degree cone, that is that the dual, or what is the relationship between that cone and the 76.345 cones? My question.
Yeah, it wasn't the dual cone. I have that image coming up here in a second.
Oh, okay.
I mean, the relationship, that's what I'm still, these are speculative now. I'm still trying to understand this part of it. The relationship I'm finding is, as these, let's just follow, like, here's a spiral that would be going around that, and the blue crosses right here, right? And right at the crossing section of those, at that black dot of Dan's drawing, right?
Right.
That's where the first golden ratio circle is. Now, he has a double caduceus, so he has a red one. So let's follow the red one that starts here at that dot. It goes to here, and then it comes back to here, right? That's the next dot. That's the next golden ratio sphere. Now, if I'm sticking with the blue one, I go to here, and then I go back to here. Oh, well, there's the next dot. There's the next sphere. But if I stick with the red one, it goes to here, and then it goes to here. Oh, there's the next sphere. So you see the crossing of those two, right?
Okay.
They're creating this stack of golden ratio spheres, right? So that's what I was trying to decipher, because then there's the pyramid at the core of that whole thing are the stacked golden ratio spheres, because the golden ratio spheres that are stacked in this are different. I have them in light gray here. See, when you put spheres in this one, they don't stack on top of each other. They're always going over. They're just kind of, they're still a stack, but they're not at these nodal points, right? And these nodal points are key. So that's what I was trying to show, that this geometry is still woven into the heart of that. It's right at the heart of it. It's right in the central layering. As we zigzag back and forth golden ratio, there's no way avoiding that this stack of spheres is somewhere inside there.
Okay.
So definitely, this is something I need to follow up with him. Maybe we'll send him this video, just this section of it, because I know he's busy, but I think he'd love to, probably see this. One other thing, Charlie, I didn't get to share this one with you much, so I'm dropping a few new ones on you here.
No, that's fine.
we got Victor Schauberger's work, which I know you might mention. I came across this image of another type
Yes.
of cone that he worked with, which was based on golden rectangles that reverse back and forth. And I found out that that is in the Russian pyramid, or the 76.345. That's the blue. And basically, if you put a circle that's half the size of this larger circle here at each of the circle points, right, of the golden ratio spheres, these four, 1, 2, 3, 4, half the size of this one, half the size of that one, half the size of that one, that's that angle of that cone. All right.
Okay.
So that was just cool. You know, it's like everything's like linked together. There was a lot of other cones and pyramids that came out of this. But somewhere in this was like the root one stacked golden ratio spheres. And then, you know, of the Russian pyramid. And then you had some variation. It's the only one that will ever have all these golden ratio spheres touching one another. It's always going to be that 76.345 angle. Then you have different ways to demonstrate how that angle will change based on using different size spheres and spacing around them. Okay. So I know this might be technical for a lot of the viewers, but it's just good to see that it's not like choosing something over another or anything like that. Everything in sacred geometry is all interlinked and connected. It's like leading you from one mystery to another to make you see, help you see connections rather than separations of material. It's like all this is a unified field, right?
Do you happen to know what the slant or slope angle is of the red pyramid that you just developed here?
Oh yeah, that's funny. I didn't even put it in there.
Well, that's okay. I think you said it was somewhere around 82 or 83 degrees, I
it
think.
was something like that. I mean, I
Yeah.
just pull it up on my iPad.
I'm just gonna say this is obviously an area for new work, additional research, but the 10 to 15% of the steeples in the Gothic cathedrals have roughly that geometry. So you may have figured out, you may have reverse engineered the remaining, steeples. We can check that out later time. Anyway,
I know you sent me that email a while ago, and you asked
yeah.
me about that, and I didn't have a reply because I didn't really know. So, but then I was like, that was a mystery for me. So I was like, where's this 80-something degree angle going to show up? And this is the first one that I had in the 80s.
Yeah. Well, that could be it. I can figure that out separately and check it out. Go ahead.
Now, this was just, kind of Charlie and I did a lot of exploring. He sent me some pictures of like a dual cone. I had no idea what a dual cone was, but I'd already been drawing it. It had already been in the diagrams. I mean, I didn't know what I drew two 76.345 or Russian pyramid cones from the four directions, two coming this way and two coming from the top, that if I just drew a straight line across here, that's the dual cone, right? So that red dish, it's a very shallow dish. I have all the angles for that, of course. And in the class, I'm going to just give you some of these that you could build for yourself, but we will draw this. But it's amazing what the sacred geometry contains, because it contains things you don't even know what you're looking at until a later date. So everything in these patterns usually means something, you just don't know. But what I did was, you could see how this two blue up here and these cones coming in from the side, and there could also be one coming straight towards you. That white dish now is the same one that just looks flat here,
Right.
but there it is from the side.
Okay.
That's just following the angle from top to bottom. That's a little spherical dish. This is tilted to maybe give you a better idea of it. What is this? I don't really know. It looked like some sort of cool thing, energy device, who knows, but it's in the geometry, worth exploring and knowing that it's in there, right?
Sure.
And figuring out how to connect it to the other forms. So, like I said, Charlie was talking about, this is one that, Charlie wasn't familiar with. Somebody in New Geometers, my Facebook group, just posted this after I started sharing about the Russian pyramid. I love my group. They share so many amazing things and come up with so many unique discoveries. That's on Facebook. You can join that. New Geometers, K-N-E-W, Geometers. And they posted this, and I was like, whoa, that looks pretty darn close to the Russian pyramid. So right underneath this blue line right here is a pyramid, right? That I just laid right over top. I mean, it is exact. There was really like a little wiggle room. It went straight from the top to the bottom, no wiggle room. And this is from 300 years ago, from George von Welling, an alchemist at the time, studying really esoteric types of things. He also had perfect segmentation of phi ratio along 4 circles here that line up precisely over circles in the diagram, which was just kind of mind-blowing to me because, you know, it goes back to Charlie's question, like the techniques to draw this right here are not really out there at all. Not that I'm aware of in any sacred geometry lesson or book or anywhere you could find how to recreate the diagram like this with 4 golden ratio circles, in addition to the pyramid slope angle, right? So that's just really fascinating to me that what happened during that dark age period that Charlie mentioned, you know, is like, where did it all go, you know? But I'm thankful that, you know, sacred geometry, you know, definitely, you know, holds the key, you know, for me to feel like this is the language, this is the pattern language that anybody can access, that anyone can access, right? And if you follow a trail, you know, you have your curiosity, your intuition, you'll be guided through these process. You know, I did this diagram of the 2 pyramids and I made something interesting out of it. But both of these pyramids are the same in here. I did this before I even saw this diagram. So to see that I created this double pyramid situation with this circle design was right here was really like, wow, I'm really participating in some sort of amazing language that just has its own universal mind or something, right? I mean, that it's just contained within these diagrams that we can rediscover and refine many of the lost things that are out there and, you know, take it further. Because, you know, shortly after doing this drawing, I was like, cool, let's turn it into a 3D model. And I built double Russian pyramids, you know, the red and the blue. And I got lucky with this one because I was like, oh, I had a ball. I said, let me just pop it in there. So I was like, it fit right inside the sphere. So that would be the shared phi ratio sphere between both these pyramids. The only place they'll share that same size sphere would be right there. And I just happen to have the perfect size ball to fit in my little model. So that'll be another fun one. I'm just going to give people that template. If you want to build something like that for fun, you'll have that available. But like I'm saying, you know, there's a lot of creative possibilities here that you can go with on your own designs. My partner and I, we did these drawings together, mirrored images of the Russian pyramid. This is the first one that we did before I even contacted you, Charlie. In fact, we did these drawings at the bottom here on 11/11 this past year. And then 2 days later, I saw your video and I said, Charlie, we gotta get together. You know?
Yeah.
We did these 2 here. And then these were another ones because this is the design technique that I discovered the night I called you. I was like, once I figured this one out, I was like, all right, that's a signal to call Charlie. I called you up. I'm glad you thought I was the Comcast guy.
Yeah, that's right.
But you know, I was started to make these. You know, we can all do this. The techniques are not as complicated as look. We'll be able to do these too. But because I have such a, you know, background in sacred geometry, different perspectives, views, it's like, let's do it with the decagon, make little slices of pizza with little pepperonis, Fironi pizza, I call this one. We got the 10 Russian pyramids going to the center with the stacked spheres. Just beautiful design, you know, would be awesome to color in. But like I said, I've got 24 different types of methods that figured out ways to recreate and reconstruct this angle, all with just doing hand-drawn sacred geometry techniques. Even though these are on the digital computer, I make sure that they're available and easy for us to do just with regular techniques. So here's a little plug just about the Pinnacle Golden Ratio Pyramid Workshop. It's coming up on January 9th, 3 workshops. I got additional content and, you know, the nets of the forms, you know, it's going to really be awesome. And here's just some of the things, you know, we're going to work on creating together, showing you how to scale the drawings, how to make it a fold up models. You can cut them out or you can have the nets to like have the perfect, you know, templates. But I want to show all the techniques to recreate this stuff that I've been coming up with. And I think it's going to be really like no sacred geometry workshop I've ever done before, because we're going to really have a nice 2D, 3D component. And it's really going to be specific around the 2 golden ratio pyramids in relationship to one another. So please check that out. Once again, you could check that out at New Geometry Courses. email me at newgeometry@gmail, or newgeometry.space has another write-up. So please check that out and hope to see you there. And I mentioned the Facebook group, New Geometers. There's 2,500 people in this group almost, and just great geometers around the world. We really feel like this group is about the art of sacred geometry. And as you can see in this slideshow, this is really a testimony to that advancement, in my opinion. So please join me there. The group is really great. They're sharing their discoveries, a lot of fantastic material. So Charlie, thank you for having me, this joint sharing, but for your audience, thank you for, having me on your channel.
Well,
and that's what I got for you. I want you to, follow up with things there. If you have any questions or you want to plug it into when you jump into yours, that's about what I've got for today.
Well, no, I don't, I just want to kind of reinforce this is stuff that obviously other people in prior civilizations have known this, but I mean, we're really getting into stuff, and we're going to see the practical applications of that here in just a minute, because now I'm going to show you that the three major free energy technologies of the 20th century all use this geometry. So, I mean, if we have enough examples in real life now that I will show you, but now we also know that from a sacred geometry standpoint, this all fits together just perfectly like a glove. So, I think this is really profound information. I can't wait for people to start to apply this, not only geometers, but I want to see people taking this in the free energy and the health sectors and start to use this and apply it, because we've just got too many examples from too many, this is what mankind's been using for thousands of years. So this is going to be I think an exploding area of interest, not only from a sacred geometry standpoint, but from technology as well. So, we're really excited to be able to bring this to you. So what I want to finish up with just briefly is to show you some examples of this geometry being used in free energy. So that's where we're going to go next, if I can get this thing to work. Let's see. Let's hold this up here. There we go. I'll start, I make Russian pyramids, and that's what got me started in this. But one of the key factors was the research that was done both in free energy and in health by the scientists in Russia with respect to these pyramids. But, in summary, they determined that if the ionization field from one of these pyramids, such as the one that's pictured here on the left, were to be reproduced electromagnetically, it would take all of the combined electric generating capacity of all the power plants in the whole country of Russia to reproduce that ionization field. And again, we've talked about this. That demonstrates, correlates perfectly with enhanced immune function. That's why I haven't been sick in 6 years ever since I started making these. And that was not the case before I started making these. Capacitors attached to the top of the pyramid spontaneously charged and blew upward into the sky. The energy field from this pyramid was measured or detected as far away as 185 miles. And there were amazing increases, as I mentioned, in immune function, life expectancy, and agricultural production, all as a result of exposure to these pyramid energy fields. So here's example number one. Now, another big example from the 20th century is the work of Victor Schauberger. We talked about him earlier. He was an Austrian forester and naturalist, and he was best known for using what he observed in nature, which were the spiraling flows of water in a stream, to come up with free energy technology. This was what was called his vortex home power generator, and it alleged to have achieved 10 times over unity in terms of free energy production. So if you needed a watt to keep it going, well, it would produce 11 watts. So you'd have 10 times over unity. And so this was essentially a perpetual motion device that generated free energy. And sure enough, when you look underneath the hood, so to speak, where Victor is standing, and you pull all of that off, you're going to find this vortex generator here. Water was actually pumped through these pipes, and that's what caused the vortex to spin at these very rapid rates and produce the free energy. So once again, 76,345 there. I'm going to show it to you as well. He observed nature. And if you go to the top right-hand corner here, he loved to study fish. These are trout. And he did examples of these. If you look at the 76,345 geometry, both from the side view and the top view of the fish here, I'm pointing to it with my cursor, you'll find that geometry is everywhere. This middle section here is called I believe this was called a repulsine device. I don't know that he ever made this, but you'll see that this geometric angle is on the back side of this generating device. You'll see it in the bottom right-hand corner as well. These were some technologies that he put together to increase the flow of water through wooden water pipes. And you'll see this 76,345 geometry showing up. And then on the left side, we have it's called the Heinkel aircraft. It was the first jet aircraft manufactured in the world. The developer of this got a lot of his technology, stole it from Schauberger, and you'll see that the 76,345 geometry, I'm pointing to it here, shows up not only in the back of the airplane, but also on the side of the airplane as well, just as it does in the top and the side of the fish. So clearly, Victor Schauberger knew about this geometry and used it, and I would imagine all of his free energy technologies. Nikola Tesla's Wardenclyffe Tower. Nikola Tesla tapped into the Earth's energies, but he used this geometry in the construction of his tower. I would presume similar to the Thiruvannamalai Hindu temple, that it organized the energy flows that were coming up from the Earth, and allowed for the production of free energy as a result. Here's an example for those of you who know about Coral Castle. This was a project developed by Edward Leedskalnin. He was a very small man, about 5 feet tall, but he built this entire complex from coral on the property. But he was able to lift these massive stones with just a tripod and a set of pulleys. And he had some very interesting technology with respect, or ideas with respect to magnetism. You can't see it very well, but at the top of the tripod, there was a box of some origin. It probably had to do with magnetics. And he used geometry apparently of the tripod in conjunction with his understandings of magnetics to be able to lift these gigantic pieces of coral all by himself. Here's another, this is a 19th century free energy technology researcher named John Keeley. John Keeley had a number of discoveries in terms of free energy, and also being able to anti-gravity technologies that he developed. But we can see on the left, I'm in the process of trying to get in touch with Dale Pond, who wrote a number of books on John Keeley's work and is kind of a curator of all of his technology and works and so forth. But I did find these in one of the books that he wrote on Keeley's work, and you can see the vortex mechanics. We see the kind of the inside of the torus there. And this very specific 76,345 geometry shows up inside of that diagram. On the right, this was one of his water-free energy devices, and you can see that the bulbs that he used in conjunction with that, water would be placed into these bulbs, used this precise geometry as well. So I'm hoping to get more information from Dale about this. And when I do, I'll be doing some extra videos on, 76345 and his technologies. So what happened to all of these technologies? The Russian pyramid research was not allowed to be published in the West. Victor Schauberger's work, he was forced after World War II. During World War II, he had to work for Hitler designing various military aircraft and technology for the Nazis. But afterwards, he was forced under duress to license his technologies to American business interests. We don't know what happened to them after that, if the US government got them or not, but they were taken out of the public domain. Nikola Tesla's research was seized by US government upon his death and has never been put out into the public. And finally, John Keely's work, right after his death, there were concerted efforts to discredit his work in the press, calling him a fraud and so forth. And most of his research notes and his machines were most likely ultimately sent back to the Theosophical Society, which was an organization that he belonged to, in order to keep it for safekeeping. But in all four of these cases, these technologies have been buried, some by the U.S. government, maybe some by other parties. But this technology has basically, been put under wraps, and it all contained this geometry. So we know that it's important, and that's why we're going through the efforts of getting this information out to the public. So again, we're going to summarize here. Follow up with George with his workshop. That's going to be on the 9th. And again, George, tell people where they should go to look that up.
Yeah,
to contact
new
you.
geometry courses. New geometry courses, KNEW geometry courses.com.
Okay. And then finally, if you're interested in our pyramids, you can purchase those at stargatepyramids.com. My partner, Lisa Richard, makes capstones and accessories for them as well at pyramidsurge.com. And in either case, if you use the coupon code NOPayPal30, you'll get 30% off of your orders. So we thank you all for listening. I'm going to stop the share right now. And George, I don't know, do you have some words you'd like to finish up with?
No, it's just fantastic to do another video with you, Charlie. And I felt we had a little less time constraints in this one than the symposium one. So we really let it go all together and we broke it into the few sections there. And I'm really thankful that both of our research streams have come together in the past 2 months, really, and that we were able to produce this awesome content and make new discoveries along the way. So I'm just thankful for all the viewers that have joined us on this journey. And look forward to maybe seeing you out the workshop or subscribing to my channel for the other sacred geometry that I reproduce. And remember, check out the New Geometry's Facebook group. I think you might really enjoy that if you have an interest learning more about sacred geometry. So that's
fantastic.
About you and everybody, and I really appreciate doing this one again with you, Charlie.
Okay, well, I'll just say this: I'm looking forward to your class. Fortunately, I knew enough to be able to come up with an idea of stacking spheres to get us hooked up together, because that's really was the missing link. So I'm looking forward to learning how to draw sacred geometric forms. Before I forget, what will people need for the class before they start?
Right. Well, the compass and straight edge
Okay.
are two things. I mean, I have a list of materials, when you sign up that will be given here, but compass, straight edge. So I don't have my tools right here, but the regular drawing compass, one that's good, one that locks into place. It's not one that you did when you were younger that made you hate geometry. Is get a decent compass. Staples or Michaels or some sort of craft store usually has the ruler, the pencil, and an 11 by 14 drawing pad, and that's it. This is totally for beginners. the techniques that are in this one are not super advanced. You know, they're not going to be really hard. It's amazed to how easy this is to reproduce this angle, but we're going to do some other interesting technical related drawings to it once you get your feet underneath you, and you're going to have extra videos to kind of take your exploration further with some other designs. So, you know, it's really going to be jam packed. We're going to do some model building for them. So really just, you know, the compass, the straight edge, and you know, you can cut these right out of the paper and make these, but I'm going to give you the printable nets and things so you can make these, which, you know, are going to have less imperfections than our hand drawn. So things like this are going to be available. I'm even going to give you all the templates if you want to go for it. I'm going to give you the whole template. You can make this, and I'll describe how you can just tape it together and use hot glue to put it together. So I'm really going all out with all this content because I have so much of it and I really want to get it out to people because it's just sitting, you know, here. And I think it's just great for people to interact with. So it's going to really be a lot of fun. I'm just thankful Charlie's going to be there. It's going to be really great to have you there.
Oh,
And
I can't wait. We're going to have to do something like this as well, I think, for the audience, so they can figure out at least how to make cones maybe on their own without all of
no,
the
we'll do
heartache
this
that I
for,
put
we'll
them
do this
through.
for the audience too. Yeah, and the course will always be there for all the content
Yeah.
that's going to be available. But we'll have a, you know, I'll do a video of the basic technique so people can do it and get started doing it in a very simple way too at some point. You know,
Great.
so
Well,
um,
well, and I'll just finish up by saying if there are people out there who are interested in either health or free energy applications, contact me if you have some serious interest in trying to explore some of these topics. We'll figure out ways that we can start some research going with you, and look forward to hearing back. But I'd particularly be interested in people who know electricity and would know how to perhaps, if we build a pyramid of sufficient size, how we could do a demonstration model of free energy technology there as well. So all of those are great ideas. So we look forward, both of us, to hearing from you. And until next time, I guess I'll just say it's we're probably out of time now. We thank you for watching, and you have a great day.
all right, everybody. See ya. Bye. Much love and peace.
Bye-bye.
Bye.